Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
All right, so first of all, in order to answer this question, we need to look at two px atomic orbitals, and then we're going to be kind of blending them together. So we've got two cases. I'm going to just separate them out here. This one on the left is going to be for bonding, and the one on the right is going to be for antibonding. So first of all, what are two px atomic orbitals going to look like? So if we have two atoms drawn with their nucleus here, this is going to be their axis of bonding. So that's just the axis that this orbital is going to point along. Sort of like this, a little bit like a bow tie or a figure eight. And now because these are p orbitals, it means that one lobe is positive and the other lobe is negative. And it doesn't really matter which I pick for this first guy. But once I've picked him, the second one does matter. So since this, I'm going to choose white to be positive and black to be negative. That means that this guy has to have its white lobe pointed towards the center because we need those two to interact constructively. So now if we imagine taking these nuclei and moving them into a distance where they can interact, we would see that this first lobe, let me draw this a little bit better. This first lobe gets much bigger. It interacts positively. And the second lobe gets a lot smaller. That's because a little bit of this positive charge here is getting into there. Or not positive charge, but positive sign. And it's canceling a little bit of that out. So this is for bonding. For antibonding, we're going to start in a very similar way. We're going to draw our orbitals in here, far enough apart that they're not interacting. And we're going to pick a designation for this guy on the left. And now for this guy on the right, we had to make sure that the positives and negatives cancel. So we need to point it like this. And so when we move these two closer together, what we're going to see is there's going to be sort of a line in between them where they perfectly cancel out. And then a little bit of a positive nub here, and a larger negative side, and then a little bit of a negative nub here, and then a larger positive side. This is for antibonding.